So since this is a homework question, you can probably guess that since it's raised to the power 9, I'm not asking you to use the binomial expansion for this. It's going to take too long. So we must be able to represent this complex number in polar form in a simple way, not involving inverse tan, or at least we can simplify inverse tan of root 3 or whatever. So to see what it looks like in polar form, it's best to actually draw this complex number. So real axis, imaginary axis. What do we have? So we've got 1 along the real axis, and we've got root 3 downwards. So this is length 1, this is length root 3, and this is our complex number. So Pythagoras, so what we're trying to find out basically is this angle here. This angle theta will be, well, actually the argument will be minus theta. So we want to know what this angle theta is. You might already know what inverse tan of root 3 is. If you don't, then Pythagoras tells us that this length here is 2, and then hopefully you realize that inverse cos of 1 over 2 is pi by 3. So theta is pi by 3, which means the argument we want is minus pi by 3. So we can write this as, okay, well, we need to know what the modulus of this complex number is. So the modulus is obviously, well, we've already worked it out, is 2. So it's going to be 2, this is equal to 2 times e to the minus I, and then the argument, sorry, well, minus I pi by 3. So this angle here is pi by 3. The argument is minus pi by 3. So all of this is raised to the power minus 9. Separating out, we've got, well, 2 to the power minus 9 is the same as 1 over 2 to the 9. So we can divide by 2 to the power 9. And on the top, we've got minus 9 times e to the I pi by 3. So we end up with e to the 3i pi. 3i pi is the same as e to the 3i pi is the same as e to the I pi, which is minus 1. And we should really simplify this 2 to the power 9. That's not the simplest form. The simplest form is if you work out what 2 to the power 9 is. 2 to the power 8, you might just know from computing, is 256. 2 to the power 9, therefore, is 512. So that's the final answer.